Dear students, let us continue with the Module 1. This is going to be lecture video 8 of Module 1. So here in this video, mainly we will discuss the core IoT functional stack. Here in the given diagram of simplified IoT architecture, you can see that this is the core IoT functional stack which has three layers: applications layer, communication network layer, and things layer. Okay, so we'll be discussing about this core IoT functional stack. So let us go. So in the core of IoT functional stack, the first layer which is called the things, which is sensors and actuators. So we'll discuss. So from an architectural standpoint, several components have to work together for an IoT network to be operational. So several components have to work together for the smooth operation of IoT network. So in this one, the first one is the things layer, then communications network layer, access network sublayer, gateway and backhaul network sublayer, network transport sublayer, IoT network management sublayer, and application and analytics layer. Now the first thing is the things layer, which is formed with the sensors and actuators. So see here. So from an architectural standpoint, the variety of smart objects, types, shapes, and needs drive the variety of IoT protocols and architecture. So here, a variety of things or objects forms the things in the IoT. So based on different criteria, all the things are divided into different categories. So first is battery powered or power connected. So uh, in the world, whatever things we are seeing today, which are connected with the internet, so either they are battery powered or power connected directly from the powerhouses. So here, this is one classification. This classification is based on whether the object carries its own energy supply or receives continuous power from an external power source. For example, mobile, laptop, tab. So these are the things or objects which have battery, which is battery power. They have their own battery. Okay. Another thing, suppose like a computer or washing machine, refrigerator, AC, they will be connected with the external power source. So whatever things are uh, added to the IoT network, it can be divided into either battery power or power connected directly from the external power source. Another criteria to divide the things is either it is a mobile or static. So whatever things it is connected with the IoT network, either it can be mobile or it can be static. It means it is a movable. Mobile means movable. So suppose your mobile, laptop, laptop, tab, they are movable things. They are mobile things. Okay, they can be transported from one place to another place. Similarly, sensors also, they are movable things. It is a mobile thing. It can be transported from one place to another place. Another thing, it is static. So here like refrigerator, cooler, washing machine, they can also be connected with the internet IoT network, but they are static. It will be uh, uh, stored at the fixed place. Next one is low power or high reporting frequency. Yes, so some objects are there, some things are there which are connected with the internet, and they need that reporting frequently. They need to be analyzed frequently. So some objects need to be analyzed very fast, and some objects which can be analyzed after long period of time. So, for example, a rust sensor may report values once a month. That a sensor which is recognizing the rust on any object once a month it will report. A motion sensor may report acceleration several hundred times per second. So another thing here, motion sensor is there. We can report that acceleration about any object several hundred times per second. So this is another criteria to divide the things. Another, it is a simple or rich data. So some objects are there which generates the data very fast, like mobile, laptop, and all those things. With the help of the social media, uh, with one click, data can be generated. But some objects are like washing machine, fridge, and all those things. They don't generate the data so fast. So it's generate the data in a simple way. Similarly, the fighter plane or aeroplane, they also generate a huge amount of data per second. So all the objects which are connected with the internet, they can be either it can be simple or it can be rich. Then report range. This classification is based on the distance at which the gateway is located. So for example, for your fitness band to communicate with your phone, it needs to be located a few meters away at the most. So here some objects which will be how far it can be located from the receiver or from gateway. Like some objects which can be placed at 1 meter distance, 2 meter distance, 3 meter distance, like that. Uh, so like here, one. And suppose a wristband is there for our health monitoring. So mobile should be located very near uh, to the wristband so that it can display the report uh, in the mobile. Then object density per car per cell. This classification is based on the number of smart objects over a given area uh, connected to the same gateway. So in the at the few distance, how what is the density of the uh, IoT objects? Next layer, it is the communication network layer. It is as we know that it has the four sublayers. One is access network sublayer. So there is a direct relationship between the IoT network technology usage and type of connectivity topology this technology allows. So each technology was designed with a certain number of use cases in mind.